Good morning, good afternoon. Depends on what time. And sorry for my voice. I'm just off the airplane. My name is Oleg Shilovitsky. What I will be doing, I will be sharing some of my thoughts about how product data and product lifecycle is connected to supply chain and sustainability. So for those of you who don't know me, I spent some time, about 20 years, working in different data management, PDM, PLM products in large companies like DaS05 and Autodesk, and also founding my company. I'm currently on my own doing consulting, and feel free to discuss any crazy ideas with me because I'm looking for one. Also probably bumping my blog online Beyond PLM, which I started 6 years ago, and I thought it was like a small deal that I will do for some time, but I've been doing it for 6 years, put about 1 million words out. Quite an interesting exercise. Made me think a lot, and a lot of discussions around it. Actually, it's very helpful to form some of my thoughts. I will speak about product data and product life cycle, and the first thing that is very insightful and important these days is everything gets very complicated. So I wanted to start with this chart. It's very interesting. You know, if you drive average luxury automobile, the number of software line codes in this automobile is about 100 million. And if you compare it to some other data, like F-22 Raptor had, guess what, 1.7 million. So basically what you do today with the products, and the car is a good example because we are all doing this all the time. Basically everything that you do in your car today, it's actually software. Because the time when you've been doing something mechanic in your car is gone. So your product is completely software based. So your steering wheel, everything you do is actually software that doing inside of the car. And the complexity of this device it's tremendous. If you think how it all operates together and how it's all designed, you just think about level of complexity. Now it brings another problem, and this is another piece of data, is we have more computers controlling function and everything, and then we have more recalls coming out of the systems. And then we have a high level of complexity, how to interoperate with all these problems together with product data and together with suppliers of these devices, because guess what, all these devices in the car are not made by a single company. All these devices in the cars and all these PC boards that controlling your mirrors and controlling your sunroof and controlling everything in your car are made by different companies, and they need to somehow cooperate together. So that's just to show the level of complexity. So basically, if you think about simple device today, the simplest possible device you can think about is a system. It's not device. If you have this tracking device and you think about this, oh, it's just a bunch of plastic or something on my hand that is tracking my activity. This is actually not, because you have this device that tracking you. You have a computer, you have an application on the phone which is somehow connected to this device in different ways, depends where you are. And you also have all this data science that helps you to analyze this data, mostly on the cloud software that you can connect with. And then it's another thing that's not obvious. You have different partners that connecting to your data to get intelligence of these devices. And some companies are getting very intelligent in the way they supply this data because they are selling this data. So think about your small tracking device. It's actually the ecosystem of a lot of things together, and it getting to the car, it's getting to anything else, all products around us with a lot of connected devices, and it's all together as a system. So basically today when you think about product data, it's not assembly of mechanical parts like we thought 10 and 15 years ago that we need to assemble together. It's assembly of mechanical parts, electronic parts, and software parts, and it's all together. And we, on top of this multidisciplinary set of data, we have different disciplines to manage this data. So we have change management, we have life cycle, we have system engineering. So that's the multiple level of complexity running on top of these huge data sets that we need to combine together, and we need to make it work. Now think about product data management and any product data. So if you go 20 years ago, it was very simple. So data means database, and database means tables. We can put data in the tables, and it's obviously we can query it. Somehow magically data will come out. So that was 20 years ago, and today it's not. Today it's completely different. So if you want to think about data today, it probably looks like this. So you have data in multiple places. Data is connected. Don't think that you can combine this data in the single big database. It won't work. So you have data which is global data distributed in multiple locations. Some of this data is on mobile devices. Some of this data in a different systems and different suppliers and different manufacturing facilities. So it's all distributed. So if you want to think about data today, the database is it's a bad paradigm to think about it. So think about network first. So what I like to say is the single database point is gone. We don't have single database point to data today. And the main point is that when you want to use this data, it's actually you want to use up-to-date data. I can give you a simple example. Yesterday I took my child to the doctor, and the healthcare facilities on one side of the street, and the CVS is on the other side of the street. And they said the medication to the CVS, and I'm coming to CVS, and they saying, when did you went to doctor? I said, we just from there. So they said, you need to wait 30 minutes. I said, why 30 minutes? Because it somehow magically should come somewhere. So if you think about all this data complexity, it's synchronizing so somewhere. So if you think about all this data complexity that comes in between different systems, you want to get updated data, because it can be the situation that you have a maintenance issue and you have design issue with supplier, and it's basically data between the OEM organization and supplier is not synchronized. So who can identify what is the synchronization point? This is an interesting question. I will come back to this. If you want to think about life cycle of the data, because data is also changing, our traditional way to think about data life cycle is when we're doing changes. So we got our design, we make changes, so we have the old part, and now we have a new part, and then we have another revision, which is obviously true, but this is only think about engineering changes. But there are some other elements that are changing. We have suppliers that are evolving. Are you using the right part? Are you using the part that's going to be outdated in 2 months, and it will not be available for you? Now we have customers that are using your product, and obviously it's also added data, because the customers are providing you information about what is going with your product. Now we have new things. We have Internet of Things, or connected products, whatever you call it. So all these devices are supplying changes and additional information. Now if you think about product life cycle, you combine it all together, and it's all changing very fast. So it's the question how you catch the right piece of information and the time that you need it. And in many situations, when many suppliers and many companies are involved in the process, it's very hard to catch that particular moment of a particular piece of data that you need. And that brings a tremendous level of complexity. Now the big data became some of the ways to think about how to solve data problems, because we can combine this data and we can somehow analyze this data. It's an interesting way to think that we can combine a lot of data and process it significantly, but the biggest problem is not how to create the biggest part of the information. The significant problem here is how to identify a particular piece of information that you need. Because if you think back about this ecosystem, it's created a tremendous amount of data, and you don't need everything. You want somehow to get to the right piece of information than you need among different companies, among different suppliers and different products. So the biggest chunk of data is probably not what you're looking for. You're looking for the right data. Now, if you think how you want to get data to come back to you, you certainly want data to come like this. So you want to come data in the way that you can understand it. You want data to come to you in the way that you can analyze and take decision. Unfortunately, it's not always happens this way, although we have a lot of new applications and new products that are doing this. But in many situations, your challenge will be this one. This is the way the data will come to you. In most of the applications running between different companies and different suppliers, you will see this data coming that way, and this is still a challenge for many companies, especially working with the different disconnected fields. Like if you think about suppliers in many fields, they are using different sets of applications that in many situations, these are applications that they're using for 10, 15 years. They are not changing. So that's the challenge. Now, if you think about some examples, so this is the, I think, latest BMW and an example of different suppliers involved in the design and the manufacturing of this car. So to connect all them together, it's a tremendous, to connect all this data together, thinking about everything that I just mentioned, that's the big product data and life cycle challenge, because you need somehow to combine it. And I remember one of the conversations that I had with one of the mobile device manufacturers about was 15 years ago. I don't want to mention the name, but the question I asked them, how do you know what software you put in your phone? So they said, yeah, we don't know actually, it magically happens. So probably 15 years it's magically happened and it was okay. But you need to know what type of software and what type of components you put in this environment. So this is the biggest problem, and this is the biggest challenge. I don't know if you had a chance to read this book. I honestly can recommend to you. So Who's Really Made Your Car? So it's a lot of examples of how actually things are connected using the manufacturing of the car. So who is producing what and how it's related together. You will discover a lot of amazing example of data integration issues and the things that are running beneath something that's called the modern car. You can think now that the problem is for the large manufacturers, so it's a problem of Boeing and BMW and Toyota and many others, but actually the problem is same or similar for somebody who manufactures small devices. So if you are manufacturing, if you're a hardware startup that's doing some fancy new devices, you have the same problem. And actually this is an interesting piece of information that 75% of Kickstarter-based hardware companies are missing targets. And why they are missing targets? Because they cannot communicate with contract manufacturers. All these companies are not doing manufacturing by themselves. They subcontract somebody in Shenzhen and somebody in Mexico, and guess what? They're sending wrong bill of materials to these guys, and then it doesn't come on time. The same data problem and the same life cycle problem, and it happens all the time. Now, how vendors are trying to solve it? When you have many pieces of data, the key word that you can hear from many software vendors is actually two options. First, let's put it in the single database. I can hardly find somebody who is trying to say it these days, because it's obvious to anybody that you cannot put it in the single database for many companies. Then another magic word that often comes out is, okay, we will do federated system. So federated system, it's possible solution. Many companies are trying to achieve it, but it's still very complex. So, but these are key problems if you think about data, product data in supply chain, that you have data in many places. And what many companies are doing It's so-called data pumping, so you basically synchronizing data between different systems, which is very inefficient. And at the end of the day, this is the same problem that I had yesterday between doctors and CVS, that I was waiting for a prescription, and it was about 20 minutes to deliver it across the street. And I said, can I go back to the doctor and bring it? They said, no, you should come through the system. Because it's connected to another suppliers in the healthcare, it's obviously if they will not get it, the insurance will not get this information and all other issues. So think about supply chain and product data, it's about the same. At the same time, if you think about many successful companies today, the key word for their successful operation is network. So if you think about data coming through the Facebook, and if you think how Uber is operating, and if you think how Airbnb is operating with them, these are huge global networks of information that surprisingly can operate in a very efficient way. Actually, I didn't plan this example. It came this morning. I was taking Uber from my home to Logan Airport in Boston, and when I came to terminal, I discovered that they charge twice for airport fees. So I see these two lines in the bill, and I'm thinking what to do. There is an option in the application to submit that you have a wrong charge. So guess how long it took Uber to fix it? It was less than 1 minute that I get an email from Uber back saying it fixed. So it's significantly more efficient that the data, prescription data coming from my doctor to the CVS. So that's something that we need to think about. But there are some technologies around on the global scale that can operate with the data in a very efficient way. And these are only 3 examples that I put. Certainly there are many others that can operate with data, with a lot of data, in a very connected way. And the key word here is a network. So what I think about possible solutions and where we need to take ourselves. We need to come to decisions workflow more than trying to put data in a single place. So the old style of thinking was, let's put data in a single place and hope for good. And it just doesn't work, it doesn't scale. So we need to come to organization of decision workflows that can bring right data at the right time. And that's why I want to leave you with one message, that we've been talking in PLM all the time about single point of truth, and we probably need to come to single moment of truth, because if we will design for single moment of truth, we will get the right information from multiple organizations and supply chain, and we'll be using the right data. So that's what I have. Thank you very much. And questions?
Something like Uber or Facebook or Airbnb work is they're operating on exactly one data model. I mean, at any point in time, they have exactly one data model, and that data model may migrate, but it's usually backwards compatible. So, this is not much of a challenge to have your single moment of truth come from this network. But in the case of the CVS, you've got multiple points of contact that all have different data models. I mean, and that's a much, much harder problem to solve. It's a completely different problem. So how do you get the Uber approach to work when you've got these 30 different points of contact that are all using different data models? That's the challenge.
Yeah, that's a very valid statement. Indeed, all these companies are operating under I would not say single data model set, but operating under single experience that they design for. And this is probably the key thing. So they are thinking about workflows, and they are less thinking about data. If you go and you open their back door, and the way data is organized, you will find a complexity of data technologies that they use for different purposes. And one of the things that in many situations, data is replicated. And why it's replicated? Because write data in a more efficient way, you need one technology, and to read data, you need another technology. You can synchronize between them. There are a lot of data science which goes on. And this is probably one of the things that we need to apply to thinking about different data sets in supply chain, because there is no way we will convince anybody to use all these companies to single data model. It's just impossible. So we need to develop better technologies how to process this data and how to get this processed data in the right time. And there are enough technology in this place that can do it. I'm not saying it's simple. I'm not saying that we will take Uber implementation and just move it, But when we go to the data science that companies like Uber are doing, we can discover a lot of very fascinating technologies that can actually solve data synchronizations problem. Yep.
This is a bit of an observation and a how do we get there from here kind of question. So the difference, the observation is that Uber, Facebook, and Airbnb are all competitive members in a network. All of these people are competing for business on their own, regardless of the value of the network. And if I'm an egotistical person, I want attention for me on Facebook. If I'm a bed and breakfast, I need customers to come. And I'm doing that regardless of the network. Something fundamentally different with the supply chain. My particular problem is satellite parts. There's a small satellite community that's exploding, and I need to know what the best right satellite component is with context. The problem is everybody is funded to hold their own list. And so because people are carrying funding forward, they're not looking for customers. So that's the observation, is that there's a fundamental difference between people that are in the entrepreneur trying to attract attention versus the people that are already paid to fill needs, like a particular member in an automotive supply chain, or it's no different. So the question, that's the observation. The question, how do we get there from here, is how do we get from the network that works and have it work with a funded network?
It's actually a very good question. The only association that I can immediately bring to this point is if you think how these companies are integrating with environmental data. An environment could be, for example, maps, traffic, or any other activities that happens. There is one very fascinating example about early days of Uber. They've been trying to figure out patterns of traffic in San Francisco, and it's obviously important in order to position cars and navigate cars. So they discovered some interesting spikes in traffic, and they've been analyzing data. So they actually combined three interesting patterns. It was traffic near bars and a particular dates, and they've been trying to connect it to prostitution. So skip to the end, they found that this particular spike happened in the time that people get paid salaries. So how you can get to this information? By analysis of a lot of data together and combining patterns of data together. So if I think about your example, you just go in proactively, getting data, creating data patterns, and only by analyzing these data patterns you can find the right places and connect the right places in the network. Because if you think about huge network of data, you can find connections between two nodes by discovering particular patterns. So that's a possible approach how you can dig to this information. And probably there is no other, at least known way how to do it, because this information will not be available on demand. Rather, if you will go and analyze this network and find patterns in these networks of information.
I'm confused by the notion of federation is not going to work. And the reason I'm confused is because to me, federation examples are like the open software movement and the way Linux, for example, was created. And more recently, the use of crowdsourcing of students to analyze genomic patterns. And to me, those are federation activities. So what am I missing?
Yeah, I think we're speaking about the same, but from a different angle. So where I got disappointed about some federated, thinking about federated systems, and when vendors created, whoever did it, implemented, created demand that you can query information online between different systems and get this data available. And it's very disappointing part because it's never going to work from my standpoint. So what the way you present it, it's actually, in my view, very, very good one, because it will allow to gather information between multiple systems and discover patterns, query information, combine the information, and then you will get better results. So that's a little bit different approach to look on this.
Curious where Uber is getting their prostitution data, but we'll save that for another time.
Need to read back their data science blog. By the way, I can recommend you in this case. There is something called Data Science blog by Uber. Read it, you will find a lot of examples. Okay. This one is going on.
There are kind of two different models here, though, because when we're talking about these folks, or traffic data, for example, it's the data just has to be good enough to be useful. So, most traffic data is collected, it's a correlation, right? It's the number of cell phones that are sitting on the highway. They're not actually measuring cars, they're measuring cell phones sitting on the highway. And it's close enough. It's a good enough correlation for us to get meaningful information about traffic. But your example about the prescription, it's your physician, your prescription, your identity, your pharmacy. Those are very specific pieces of information that are critical. Good enough is not good enough in that case. It has to be absolutely right. So I'm just curious how you would extend, this type of a model to that type of a situation. And the other piece is the connection between real time and perceived real time, because you have, if you had gone to get a cup of coffee or lunch before you went to the pharmacy, you'd think, oh, wow, I go to the doctor, I run across the street, and my prescription is there. But in fact, as you said, there's a synchronization that has to happen between different data systems for that real-time exchange to actually occur. So I don't know if there's a question in there, but how do we go from this type of correlation type data to very specific data that more mission critical, if you will, type data that has to be absolutely right?
Yeah, I cannot say that I have a recipe, because otherwise I would not be standing here but actually doing that. But I think we both agree that there is a problem here. So it's how to do that, how to jump from particular specific prescription to particular part number of the part, a component, to discover it on the airplane, and it should be provided with maintenance or replacement or anything else. So this kind of problems. And sometimes it's real time is good enough until plane will land in the next location where it should be replaced. And sometimes it's not good enough. So I don't know. But for some decisions, it will be good enough. For some decision workflow, it will be good enough, and for some decision workflow, it will not. And then you need to figure out how to do it for something. And then, like I said, I can go to have lunch, and airplane can spend 2 hours in the airport and wait. So if it works for companies, it's fine. If it don't, so it's a problem.
So part of this problem has been solved in the U.S. by the Department of Justice in a program called the National Information Exchange Model, NIEM. So anybody in the U.S. who knows what the Amber Alert is, something happens in one state and all of a sudden across all states, everybody is broadcasting this on a overhead display on the highways. And so the NIEM is something that enables that. So I would just offer, and as you look at solutions, the kind of systems of systems problem that you're describing here, there are some solutions out there that might prove useful in terms of how you think about supply chain.
Mm-hmm. Okay, thank you. That's a good information.
Anyone else?
Sorry, it's actually kind of a follow-up on that as well, because you also have that personal privacy issue, and intellectual property protection and regulatory compliance that you have to deal with as you're going from the network at the doctor to the network at CVS and the network at the pharmaceutical supplier, making sure that they de-identify the information about you and your daughter when it gets to the pharmaceutical company. But CVS obviously needs to have that specifically in order to be able to make that connection work. So you can't always standardize the data between the networks if you have those things like security, regulatory compliance, intellectual property protection, and personal information protection. So that becomes the reason that both the cross-network federation becomes that extremely difficult problem. Whereas if it's all within one network, it's within my organization, I at least have a fighting chance to do the federation the way that Jack described it.
That's a very good point, a very good example. I guess similar problems we can see in supply chain networks as well, when we have different networks, different supplier, different authentication of the data, and not everybody wants everybody to see all data together. So I can only remember that the two questions that people are asking when you're working on the data retrieval system, and I've been doing search. So the first I said you can search. So guess what was the second question? The second question, how we prevent people from searching. So that's exactly going to the point.
I think the Amber Alert example is a good one because notice the word broadcast. So that the notice can be put out. However, they do not have the ability then to bring in intelligence from any point in the periphery and bring it back in to isolate what's really going on. Right? And the reason that this doesn't happen is because that brings us into the world of conditional graph processing, and all we have are computers that were designed to do arithmetic. And every time you try and do a conditional graph with computers, the runtime goes to hell. And so those interested would be probably interested in looking at the new thing that is not yet been formally announced by Micron Technologies, but they have brought out a thing called an automata processor, which is not as wide as the brain. It can only handle 65,000 simultaneous recognizers, but it's going to revolutionize our ability to deal with conditional graphs.
Okay, I guess it was not a question how it will work, right?
Okay, thank you.
Okay, thank you.